Hello GMAT aspirants, welcome back to yet another episode of GMAT Friday with IMS International. This is your quant mentor Anirudh Murarka. We are going to be solving a question on number properties today. This is a fantastic question on factorials. You know the drill. Pause the video, give it a shot, and then resume to look at the solution. So this question is an application of a very famous brand of questions that talks about how many zeros are there at the end of 0 factorial. So firstly, let's try and understand that concept, and using the learnings from that concept, we will try to solve this question. Let's say if I ask you, what is 1 factorial? I hope everybody knows the meaning of factorial. It means multiplying all the natural numbers from 1 till the last number, right? So if I talk about, let's say 2 factorial, the value would be 1 into 2, that is equal to 2. If I talk about, let's say 3 factorial, it would be 1 into 2 into 3, that is 6. 4 factorial would be 1 into 2 into 3 into 4, that is equal to 24. And similarly, 5 factorial would be equal to 1 into 3 into 4 into 5, and that is nothing but 120. Now, if you look at these 5 numbers, you will see that 120, that is 5 factorial, was the very first number at the end of which I saw a 0. Why wasn't any 0 present over here or here or here or here? If you look at it closely, if you think carefully, you will understand that in order to make a 0, I need to multiply a number by 10. Without multiplying by 10, I cannot get 0 at the end. And in order to get a 10, what do I need? I need a 2 and a 5. These are the two most important prime numbers that I will require in order to make a 0 at the end. The problem was, over here, I didn't have a single 2. I had a 2 over here, but I didn't have a 5. I had a 2 over here, but I didn't have a 5. I had a 2 over here as well. In fact, if we look at 4 has 2 2's, but still we didn't have a single 5, and therefore we were not able to make a 10, and therefore we were not able to get a 0 at the end. But when I look at this number, I had my very first 5 over here, and that's why I could make a 10, and therefore this number ended in a 0. Let's take 6 factorial. It would be what? 1 into 2 into 3 into 4 into 5 into 6. Now if I look at this 6, I am not going to have another 5 in this 6. It will contribute another 2, but hey, there's no point in increasing the number of 2's unless and until we don't have a 5, right? So even 6 factorial, the value of which is 720, is going to end in a single 0. So think carefully, when is the next time where I would get another 0 at the end? The point where I will get another 5. So therefore, I won't be getting another 5 in 7 factorial or 8 factorial or 9 factorial, but I would have another 5 in 10 factorial. What is 10 factorial? 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10, and 10 is nothing but 2 into 5. And therefore this will give me another 5, therefore this will give me another 10, and therefore this will give me another 0 towards the end of 10 factorial. So the value of 10 factorial is what? 362888800, right? Now let's say if I ask you, which would be that number which would have 3 zeros, which would be that factorial that has 3 zeros towards the end. I hope you know this, or you are able to calculate this by now, that the number would be 15 factorial, because 15 factorial would have 5, 10 and 15. All of them would be contributing 5, 5 and 5, and therefore I have got 3 5's and abundance of 2. So I am not wasting my time in calculating 2's, but do know this, that 2 was very important. If I have 10 5's with me, but not even a single 2, I won't have a 10, and therefore I won't have a 0 at the end. So 2 is very important. We are disregarding that right now because we know that every second number is going to contribute a 2, but every fifth number is going to contribute a 5. And therefore we are just bothering ourselves with counting the number of 5's. But 2 was an important thing. Similarly, if I ask you how many zeros would be there at the end of 20 factorial, Your answer should be 4. 5, 10, 15 and 20. These 4 numbers would be contributing a 5, and therefore we will have 4 tens with us, and therefore we will have 4 zeros towards the end. Now, to be honest, we don't care what would be the value of 20 factorial. We are just interested in finding out the number of zeros at the end of 20 factorial. Alright, now if I ask you how many zeros will be there at the end of 25 factorial, if your answer is 5, you are mistaken, my friend. Why is that? Because 5 will be contributing a 5. 10 will be contributing a 5, 15 will be contributing a 5, 20 will be contributing a 5, but 25 would be contributing 2 5s. So therefore, the total number of 5s that I will have would be 6, and therefore the total number of zeros at the end of 20 factorial would be 6 and not 5. Okay, now what if the question wasn't 20 factorial or 25 factorial but a bigger number? Let's say if the paper setter asks me that calculate the number of zeros at the end of 130 factorial. Now, do I have the time of counting each and every 5 manually? I do not. So we would be using a smarter approach. We would just be counting the number of 5s, because that is what we need in order to make a 10 and therefore in order to make a 0. So firstly, my step would be to count the number of 5s, and therefore I get 26 5s. Every 5th number would be a multiple of 5. So 5, 10, 15, 20 and so on, 100, 105, 110, 115, 120, 125 and 130. All of these are going to contribute a 5. But we just saw that there are going to be numbers that would contribute 2 5s. What are those numbers going to be? Yes, multiples of 25. So now my next step would be to count the number of multiples of 25. And how do I do that? In the same way, I counted the number of multiples of 5. So 130 over 25 would be how much? It would be 5 point something. But whatever is that decimal portion, we would be disregarding that because we are not interested in it. Now, let's check what are these 5 numbers for easier understanding. So 25, 50, 75, 100 and 125. All these 5 numbers are going to contribute 2 5s. But wait, if 25 is a multiple of 25, it was also a multiple of 5. So 25 which had 2 5s, one of the 5s was already counted over here. So please don't make that error of counting this 5 again. We are just interested in this 5. So these 5 multiples of 25 are going to contribute one additional 5. There were 2 5s, but one of those 5s was already counted in these 26 5s. So don't make that error of multiplying this 5 with a 2. There were 2 5s, no doubt about it, but both of them are being counted separately. One in multiples of 5 and one in multiples of 25. But wait, there's one very specific number over here, that is 125, which will contribute 3 5s. And therefore, I will have to consider such cases as well. And therefore, now I would count the multiples of 125 as well, because any multiple of 125 would be contributing 3 5s. 2 of them which were counted earlier, one in multiple of 5s and one in multiples of 25. So my last step would be to count the multiples of 125, and therefore I will only have one such number, that is 125 itself. So if I add all of this, what do I get? 32. So therefore, up till 130 factorial, I will have 32 5s and I will have a lot of 2s, which will help me make a total of 32 10s, and therefore which will help me make a total of 32 zeros towards the end. Right, and therefore if this was the question, how many zeros are there at the end of 130 factorial, my answer would have been 32. Now let's take even a bigger number. What if the question was to count the number of zeros at the end of 1000 factorial? what do I need to do? Firstly, I will calculate the number of 5s, or let me put it in a better way, I will firstly count the number of multiples of 5, and that would be how much? 1000 over 5, that is 200. What would be my next step? Calculate the multiples of 25. Now understand, dividing 1000 by 25 is as good as dividing 1000 by 5 two times. Now, this part we have already done and got the answer as 200. So rather than dividing 1000 by 25, what I will do is I will directly divide this 200 by 5, right? So 200 by 5 would be how much? That would be 40. I'll keep on dividing these answers by 5 till the time I don't get a 0, right? So 40 upon 5 would be 8. 8 upon 5 would be 1. I am disregarding the decimal portion. I hope that logic is clear to you. And 1 divided by 5 would be 0. So we are not bothered about that. And if I add all of them, what do I get? 249. And therefore 1000 factorial will have 249 zeros at its end. Just for your clarification, this 8, how did I get? 1000 over 5 into 5 into 5. And how did I get this 1000 over 5 into 5 into 5 into 5? That is 625. So any multiple of 625 will contribute 4 5s. And therefore we are getting one such multiple. And you should not be wasting your time in doing all of this. Just divide by 5 once and then keep on dividing by 5 till you get the answer as 0 towards the end, and then add all these answers. Now, that same logic we would be using in the question that was asked to us. What is the highest power of 12 that divides 1200 factorial? That means I need to find out how many 12s I can put in the denominator so that I can get a legit answer. I can get an answer that is a natural number, right? If you look at the options, you will see that the numbers are huge and therefore there is no point in manually counting it. So therefore we would use the same approach that we used for counting the number of zeros. The only difference is, in order to make a 12, in that case, in order to make a 10, what did I require? A 2 and a 5. And therefore, in order to make a 12, what will I require? 12 is nothing but 4 into 3. And 4 is what? 2 into 2 and multiplied with the 3. So therefore, in order to solve this question, I must find out how many 2s I have so that I can calculate how many 4s I have. And I also need to calculate how many 3s I have. Now you know the drill. Let's try and calculate the number of 2s first. So 1200 divided by 2, that would give me 600. So every second number will contribute a 2. And every fourth number will contribute 2 2s. Every eighth number will contribute 3 2s, and so on. So rather than dividing by 4, by 6, by 8, I'll start dividing this number by 2 till the time I don't get a 0. So 600 over 2 is 300, then 150, then 75, then 37, then 18, then 9, then 4, then 2, and then 1. If I add all of this, what do I get? 12, 20, 29, 33, 35, 36, 8, 15, 18, 19, 7, 10 and 11. Therefore, I have got a total of 1196 2s. Now, if I have 1196 2s, how many 4s I can make? In order to make 1 4, I require 2 2s. And therefore, if I have got 1196 2s, exactly half of that would be the number of 4s that I can create. So what would be that? That would be 598. So my first part of the question is done, where I have figured out how many 4s I am going to have. What would be my next part? To figure out how many 3s I am going to have. So let's start. So 1200 over 3, that would be 400. Then I'll again divide this by a 3. That would be how much? 133. It's very important that your division skills are on point. 133 over 3 would be how much? 44. right? 44 over 3 would be how much? This would be equal to 14. Again divide by 3 would be how much? 4. Again divide by 3 would be how much? 1. Therefore, the total number of 3's that I have would be 4 plus 3, 7, 11, 15 and 16. Then 4, 8 and 9, and 4 plus 1, 596. So, I have got a total of 596 3's with me. Now I need to figure out how many 12s I can make, because in order to make a 12, I require 1 4 and I require 1 3. Now whichever is the smaller number, obviously that is going to be the limiting factor, that is going to be my bottleneck. So therefore, if I consider both of these cases, I can make a total of 596 12s, and 2 additional 4's would be left out and I cannot do anything about it. So the question was, what is the highest power of 12 that divides 1200 factorial? We calculated that I can get a total of 596 12s, and therefore 596 would be the answer to this question. If you got option B as the answer, that was absolutely correct. I hope you were able to understand this concept of counting the number of zeros and were now in a position to understand how to apply in questions like this. If you liked the video, please make sure to like this video and subscribe to our channel for more such insights.